Hey, good morning everyone. Here's the stuff that I use. This is my inflatable water tub. I can almost fit my whole body inside of it, and it fills with water. And it's just pretty convenient. And over here, this is where I store my ice. Nothing unusual about this. This is just a freezer. And I use lots of frozen bottles of ice as my ice cubes to go inside of my tub, my inflatable tub. Yeah. Woo. I'm in a tub of ice. Check me out. It's an inflatable tub, and looking out my door. It's a pretty day. It's morning, and I just got finished running. I ran about 5 miles, did some sprints. I'm preparing for a half marathon. And right now I'm recovering myself. I'm speeding up my recovery. And how am I speeding up my recovery? Well, I'm in a tub of ice. I'll let you have a look at this a little bit. It's a tub of ice. I have about 15 or 20 bottles of ice in here with me, and this inflatable tub is filled with water. Just a new toy that I bought, something to play with to help me recover. And yeah, so why am I doing this? Why am I in a tub of ice, like ice water? Like, how does this help me? Like, what's the benefit of this? Okay, so a tub of ice or ice water, I consider it like a replacement for the sun or a supplement for the sun. This is one way to put sun light and energy into your body. And that's kind of what I'm doing. I'm replacing nature. Or I'm supplementing nature, not replace nature, because nature is irreplaceable. I'm supplementing nature. I'm using the cold to my advantage. So you're probably thinking, how is this supplementing the sun? Well, there's two sides to the sun. There's the actual part that gives the energy, and there's the part that receives the energy, the magnetism. Well, that's what I'm doing. I'm putting some of the magnetism back inside of my body so that I have an even greater ability to absorb the sun. So that's what I mean by I'm supplementing the sun by doing this. What are some other reasons this helps you absorb the sun? Well, it makes you more magnetic. And like, what do I mean by magnetic? There's a couple of ways you can increase magnetism in your body. You can eat food. Certain foods increase magnetism. Certain polyphenols in the food that gives it color increases magnetism because it helps you make melanin and which allows you to absorb the sun. And well, it catches the sun, which that's magnetism too. Being able to slow the sun down or catch the sun. You could also increase magnetism by dropping the temperature. Light slows down in cold, and when you slow down light, you can make stuff. That goes back to Einstein's equation, E=mc², where the c is light. And if you flip the equation around, energy divided by mass equals light. If we decrease the c, or we plug in a number that's a smaller number into the c, it will increase the mass, which means things will get made. And where was I going with this? Yes, magnetism. So cold slows down light, which is a good thing. So you can make energy by slowing down light, or you can fix and you can replenish things by slowing down light. And when you plug cold into the equation, you slow down light, which creates more mass. According to Einstein's equation for everything, energy and everything. So those are two ways you can do it. You can increase magnetism through food, which it's not the best way. It's a good way, but it's not the best way. You can do it through temperature, which is what I'm doing now. And I'm going to talk about one more thing that increases magnetism that we don't really think about, know about, talk about. And that other thing is water. Water can become more magnetic because water is a battery. Water holds light. And I'm going to talk about how cold. I'm going to talk about cold. I'm going to talk about how cold affects your body and how your body gets your mitochondria to make energy, burn fat, and create water. And I'm going to talk about the water that your mitochondria make and why this water is different, magnetic, and special. Okay, so where shall I start with this? Okay, so let's start with when you expose your body to cold temperatures. When you suddenly are exposed to cold temperatures, your body responds in your brain, nervous system responds in some really abrupt ways. Cold threatens your survival, and your body has to stay like a certain temperature in order to maintain and keep itself functioning, being healthy. So when your body experiences cold, it knows that it's threatened. So what does it do? It tries to stay the same. It stays the same by creating heat. And how does your body create heat? It creates heat by getting your mitochondria to burn fat or make energy. So your mitochondria burn fat and they make free heat so that you have energy to keep you alive and heat your body up. And when you burn fat is basically electrons, negatively charged energy, that's magnetism within itself. Electron is like a negative charged particle. It means that you're pulling in energy. Electrons, it means that you're pulling in energy, and fat is basically electrons. So it allows you to pull in more energy. It allows you to be more magnetic. So your mitochondria burn fat in order to get the electrons from fat. When we eat food, your digestive system breaks down the food. When it breaks down the food, it basically strips the electrons from the food, because that's one of the main things that we want from the food, to strip the electrons. And when it strips the electrons from the food, it circulates those electrons through your blood and sends it to your mitochondria, which are the energy making bacteria that there are thousands of them on each one of your cells. And they feed your cells. They have a symbiotic relationship with your cells, which means the cell provides a home, the mitochondria provides the energy for the cell. So the electrons are fed to your mitochondria when you break down fat or when you eat food. And what else do your mitochondria eat? Your mitochondria eat or consume oxygen. When we breathe, you're giving your mitochondria food. You're giving them oxygen. So those are two inputs to a mitochondria. One being oxygen and one being electrons that you get from food or from your body fat. So what happens when your mitochondria get oxygen and get electrons? They output something. They put out three things. They put out CO2, which is carbon dioxide. We consider it a waste product, but I'm pretty sure it's not waste. Nothing's waste. And it produces ATP. ATP is basically energy, usable energy, or chemical energy for the body. And it produces water. So yes, your mitochondria actually make water. They make water from burning fats or burning fuels from our body. So we know about the ATP. ATP is basically energy. You think mitochondria, or they just make, make ATP. We think mitochondria just make energy, but it makes, I mentioned CO2, and it makes water. So let's talk about the water. Why do mitochondria make water? Can't we just drink water, and can't we just get water like just by drinking it? No, it's not that type of water. It's a different type of water. It's a very pure, a better water, a water that has the ability to hold and store light better. So I guess you can call it light water. You have light water and you have heavy water. And mitochondria make light water. Now, what is light water? Well, in order to know what light water is, let's talk about what heavy water is. Heavy water is water. Water is H2O, 2 hydrogens, 1 oxygen. The 2 hydrogens are negative. The oxygens are, The 2 hydrogens are positive charge, and the oxygen is negatively charged. And so they're magnetic. They can water's a battery. You have a negative and a positive. So that makes it's a battery, and it can hold magnetism. But where was I going with this? Kind of lost my train of thought. Okay, so I was talking about yes, heavy water. So with heavy water, you don't have just the hydrogens, the positive hydrogens and the negative oxygens. You also have like an added neutron. A neutron is a neutral charge part of a molecule. It carries a neutral charge, and so it's a neutral charge. So it doesn't give any energy either way. It's not using energy, it's not taking energy, but it's providing a mass, and it's providing a mass. And is this a good thing or a bad thing by it providing your water having extra mass, which is why it's called heavy water? Well, with water, it's in your biology, it's not a good thing, because this extra mass is energy, but it's energy that's not readily usable. If you think about Einstein's equation, E equals mc squared, it basically means that to increase energy, you can either increase the mass or you can increase the light. So you would think that the water, by increasing the mass, you would increase the energy. Yeah, you do increase the energy, but it's not usable energy. That mass is energy that can't readily be used. That mass has to be converted some kind of a way. So it's really kind of useless for your biology and for you to use. And it takes up space and how much light that water can hold. So when you have heavy water, it can't hold that much light. Heavy water does not have the ability to hold that much light. So why am I talking about this? Why am I talking about heavy water? Okay, so I'm talking about heavy water because your mitochondria produce light water. When you take in oxygen and electrons, it produces the CO2, ATP, and light water. And this water is very special. This water can hold lots of light because it doesn't have this added neutron or this added mass to take away its ability to hold on to light. So you start producing that water, and that water is very magnetic. This is the part of magnetism that I was talking about earlier. This type of water is very magnetic, and like a lot of scientists are like finding ways or studying how to use this water as like a way to heal sickness and just make us healthier. Like we're learning a lot about this, and this type of water is found in nature. And I would need another video about that to talk about it. But this water is found in nature, light water. And some water can be lighter than others, which means it would hold more energy than other water. So that's like one of the major reasons why I'm taking my ice baths, to help my body produce light water. And it produces light water by burning fat. You know, you burn fat because fat is full of electrons, and you burn fat, your mitochondria burn fat, it strips the electrons, and when your body takes in, when your mitochondria and your body strip more electrons, it also has to take in more oxygen, so your body gets oxygenated. Okay, so I got a little bit cold, so I had to pause the video for a moment. But I was talking about your body has higher oxygen in it. Higher oxygen in your body, it means the pH has gone up. You know, higher pH means there's more oxygen in something, and it's less acidic. And you know, oxygen carries a negative charge, and light follows oxygen. So when you get cold, your body pulls in more oxygen, which, you know, that's another reason why it pulls in more light. So that's what I wanted to just hit in the video, and talking about my ice baths and why I take ice baths and how it's a supplement for the sun by making you more magnetic and more absorbent to the sun. Like people think that the sun's a bad thing, but sun's not a bad thing. The sun's only a bad thing if you don't have the ability to absorb it. And what I'm doing right now, I'm increasing my magnetism. I'm increasing my ability to absorb it. And of course, many people are different based on our genetics, based on our mitochondrial DNA. It determines like how we make energy. And some people think it's just like a dark skin, light skin thing, or white skin, black skin thing, but it's way deeper than that. It's also related to mitochondrial DNA. You know, your mitochondria function differently in different environments. Like some people's mitochondria are made to burn lots of fat in order to make lots of light water. Like if you have trouble like getting your energy directly from the sun because of your genetics, another side of this is being able to do it through water. And one way to make water, light water, that I just talked about, is through your mitochondria burning fat. And one way to do that is through cold temperatures, which is what I'm doing right now. I'm using the side of nature that I don't have here. Like I'm in a tropical climate, and I'm using the cold, since I don't really have the cold, to increase my magnetism in this tropical climate. And I'm also in a really busy city, and there's less nature, and there's lots of ways that being in a busy city is stealing energy from me. So what I'm doing is I'm getting some of my energy back by increasing my magnetism. It's one way to counteract or mitigate living in a city, you know, which is temporary. I'll be here for another 7 months, but until then, you know, it's good. Knowledge is power. It's good to know ways around things. So I'm about to get up out of this because it's freezing. It's freezing cold, and thank you for joining me. I really appreciate it. And I'll let you go. I'll see you again. And until next time, stay warm Bye, I'm gone.